Okay, this is the last vocab of the season, of the school year, chapter 8 and 9. Let's get going. First word, quadratic function. It's a nonlinear function whose greatest power of a variable is 2. So what that means and what that looks like is that this one is the standard form for an equation right here. Whoops, I need a pen. Right? Where A is a number, B is a number, and C is a number. Now, they can be any numbers, and sometimes the number is 0, but it does have to have this term because it has to have the x squared. Okay, has to have an x squared for it to be a quadratic function. Next word, parabola. So parabola is the U-shaped graph of a quadratic function. I think people are getting pretty used to that word, but that will be one of the words on the test. So that's called a parabola. Last word on this slide is vertex. Once again, this is a word that we've been using quite a bit. Vertex, the point where a graph changes direction. So if a parabola comes down and stops right here and then starts going back up, this point is called the vertex. Same thing if it's going up, 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 and then starts going back down, this is the vertex. It's where it changes from going from increasing to decreasing. Okay, hit pause if you need it. There's the bell. Axis of symmetry, the vertical line that divides a parabola into two symmetric parts. So this is the axis of symmetry. It takes this parabola, and if you were to like fold it over in two, this is where you would fold it, and then it would meet up on either side. You should know this word from doing stuff in geometry, like transformations, possibly back in middle school or something. But this is called an axis of symmetry. It's where you could fold the shape in half, and both sides would meet up. So it's like a mirror image on either side of that line. Zero of a function. It's an x value of a function f for which f of x equals 0. It's also the x-intercepts of the graph. So on a graph, these are the zeros right here and right here. And it's where y equals 0. Notice that this point isn't up any and isn't down any. Y is 0. But it does have an x value. So this might be over 3, and this might be over -3. So those would be the two zeros of the graph. You don't have to see a graph to get them. So it could be something where at -3, the number is 0. This is for like an XY chart. Excuse my bad handwriting. -2, oh my goodness, that's really bad. It's -1, -1 is -3, right? And then you keep going. Whoops, let me extend this a little bit. You keep going and you would see a pattern where way down here at 3, it would come back to 0. So, there's other things in here. I'm not putting in every value. But the idea being that here at the top, -3, you get 0. Boom, there's my 0, and there's my 0 of the graph. So you can find them from a table, you can find them from a graph, and you can find them mathematically by putting in 0 for y and solving a quadratic. One of the ways we've learned how to solve a quadratic. Okay, hit pause if you need to. Minimum value. So when you graph a parabola or when you're dealing with a quadratic function, there'll be some point, and it's the vertex where it changes direction, right? Well, if that's the lowest point, if it's the lowest output for y, then it's called a minimum. It's the smallest value for y, and the opposite of that is a maximum value. So you either get an upside down parabola with a highest point and no lowest point because it keeps going, 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 or you get a regular parabola with a lowest point and no highest point. So it'll either be a highest point or a lowest point, and we call that a maximum or a minimum value. They're usually one of the interesting parts we want to know about what's happening with the quadratic in a real life situation. Okay, hit pause. Roots, the solution of a polynomial equation. They can also be called solutions or zeros. So not sure where the word roots comes from. Maybe another math teacher knows. But that's another word to say the answer. So when you solve for x, those are the roots. Completing the square. Okay, you were probably wondering about any extra credit that you could get out of this. If you're actually listening to this, put a square around the word completing the square. Haha, he. And if you do that, I'll give you some extra credit when I'm checking your vocab. Completing the square is a method of solving quadratic equations in which the new constant term is added to the equation to create a perfect square. What I did here was drew algebra tiles for x squared. Well, I didn't do it. Got it off the internet. X squared plus 6x plus blank. So this method of completing the square is to fill in that blank. Well, you'd have a 3 by 3 part right here. So that blank must turn into a 9. So if I was to complete this square, it would become x squared plus, oh wow, 6x plus 9 for this one, because 3 times 3, this missing piece down here, is a 9. And then remember, the reason that we'd even want to complete the square is so we can easily write it in its factored form. So when you have a perfect square like that, you get x plus 3 squared in its factored form. So somebody asked me in class, well, why do we even care about this 9? Why do we have to put that in? You know, isn't this what we're really going for? And I said, well, actually, yes. But we do need this piece of information usually to solve it. But this is where we're going, is to get the factored form. Okay, and the last word, there's 10 words in this one, is quadratic formula. So a quadratic formula is a different method of solving quadratic equations by inputting the values of a, b, and c into a formula. This guy is called the quadratic formula. We'll study it here over the next couple of weeks. Um, you'll learn it. You'll never have to memorize it. I'll always give it to you if you want it. It was on the park cheat sheet and stuff like that, so you never have to memorize this. But it's really helpful to know this is out there because this can bypass any of the other methods we've used to solve quadratics. Okay, so both of these are different methods. Our other method is graphing. Our other method is factoring, where you make the box. So there's 4 different methods we will have learned to figure out what x is when you have a quadratic equation. Okay, that's the whole video. Should be pretty short. Get ready for the quiz, 7 minutes. Talk to you later, bye.